Now that we have our axes set up, we can start adding data to the plot. So after our axis commands or axis function calls to create the axes, we can use the function points to add points to a graph. And these are going to be scatter plot points. And we give it two vectors, just like we give plot to tell it where to put the points. And so we can just copy and paste our x and our y arguments from plot, because these are the same arguments that plot passes on to points in order to create the points when we use that function. So again, we have our experiment times and the concentrations through that experiment time. I can run this function, go back to our PDF, and there's our exponential decay. And you can see how our first and last points are a little bit farther from the edge of the graph, both the top and the bottom and the left and the right, because we customized the x-lim and the y-lim in the code. We can also change what the symbol we use for points using the PCH argument. Now the PCH argument, the default value is set in par using graphics parameters. So I can use the par function, and I can get the default value for PCH using the par function. And you can see that value is 1. And 1 happens to correspond to the circles that we're seeing in this graph. So if we change the PCH argument 2 points from 1 and make it 2 instead, we can see what that does to the graph. And now instead of circles, we have triangles. So there are different PCH integer values that you would pick for getting different symbols, and there's multitudes of those symbols available on the internet to look up a table of the symbols. So that's how you can pick particular types of symbols to use for points on the graph. It's great to have data on our graph, but we can't really tell anything about what it means if we don't have any labels on our axes telling us what these data are. So the way we can add labels to axes or labels to various different parts of the graph is with the title function. So the title function has different arguments you can use for adding different labels to different parts of the graph. Now there's other ways to add labels, but this is the simplest way to add them if you want them in their conventional locations along the different axes. For example, in our case, we want to add a label for our x-axis and a label for our y-axis, and we can use the title function to do that. So after we call points, we can call title, and we'll have an xlab argument. In this case, the x-axis is time, and the y-axis is concentration. So if we run this code and we look at our PDF file, now we can see we have axes, time for the x-axis, concentration for the y-axis. But this still isn't quite good enough because we have numbers here, and numbers don't really mean anything without units. So let's go back and make sure we add units to our axes. That's typically done in parentheses. So time in this case, we're thinking about it in minutes. And it's kind of made up data, but let's just say we're thinking about concentration in milligrams per liter. I'll run this again. Look at our updated PDF. We can see milligrams per liter and time in minutes. Now in graphing, we're talking about quantitative mathematical values here. And often in graphs, we want to show different numerics or variables in mathematical notation in our axes or in our legends, that sort of thing. So right now we have milligrams/liter. My preferred method for showing units is with exponents as opposed to operators like the slash. So I'd like to show concentration as milligrams per liter, where the per liter is specified as a capital L with an exponent of -1. There is a way to show math notation in R, but you have to create an expression for the label. So if I go back to R, I need to give, instead of as a string, a character string as dictated by these parentheses, I need to create an expression. And that expression can then be evaluated by the rendering agent for graphics in order to create mathematical notation in my graph. Now, how do we put an expression together? Well, if you do a help on plotmath, plotmath is what R uses, or what the rendering agent uses, to turn the code that we use for mathematics into some rendered version. And it's kind of similar to LaTeX, but not quite the same. So you have to look up the differences. Now, what we're really interested right now is a superscript, because what we want to do is put in an exponent. So in order to show a superscript, you can use an upward caret to do a superscript. Now, there's also other things about making expressions in that it's a mathematical code similar to LaTeX code, which means spaces don't matter. So when you make an expression, in this case, I want to make an expression from a y-axis, I can use the function expression to do that. So ultimately, I need to turn this concentration milligram per liter. I want to get rid of that slash, and I want to have a -1. So I can put in curly brackets with an upward caret of -1, and that will give me an L to the -1. But the problem is the rest of this is plain text, and I need to feed it into this notation as an expression. And the way I can show plain text as part of my expression is to put it in quotes. So basically, I'm going to put everything that isn't the capital L to the -1 in quotes to say that, well, this is not mathematical notation, it's just plain text. So the concentration of the milligram, including the space, will be plain text. Then between every element of an expression, I need either a character like that, which is a tilde character, which will introduce space, or I need a divider character, the asterisk character, which will break up the expression into parts. I can't just put space here. An expression doesn't know how to deal with that. So I'm going to put the asterisk character here to say I want the L to come after this quote with no space. And then finally, I have no space, and I need to put quotes around this closed parentheses that I want to show up in my expression. So just so you can see this better, I'm going to put this on multiple lines. I'm calling the function expression, and here I am building the expression. The expression is built from a chunk of plain text in quotes, then a divider between elements of the expression with no space, and that's because I've got a space after the MG here, so I don't have to add any additional space. And then I want no space after the L to the -1, and then I'm going to put in quotes a closing paren for the closing paren of my label. So if I've done this correctly, I should be able to run the code. And now you can see, well, it's trying to put an L to the -1, but it looks like I've bled off the edge of my canvas. So because of where the title is putting this, I haven't left enough room with my margin in order for me to be able to see this new label. And it's because I've added this exponent, which adds to the top of my text. So I can fix that by going back to my code. And remember, we set what those margins were. This is the bottom margin, this is the left margin, this is the top margin, and this is the right margin. So it's this left margin that's too small. So let's add 1/10 of an inch there. Call this 0.9 instead of 0.8. That should give us more space on that left side. I can rerun this code, and there we go. I've got time in minutes, concentrations in milligrams per liter in the mathematical notation that I prefer for those types of units. And the way I did that was with an expression. So this is yet another language that you have to learn in terms of building expressions in R that will then be interpreted by plotmath when you render this into a graph, and you can start putting mathematical notation on your graph that way. Just to get a little more practice with expressions and how we build expressions, we can use fewer quotes in order to build this particular expression for the label for our y-axis. I don't necessarily need a quote here as long as after the word concentration, I use a tilde to provide the space that I want in between the end of concentration and the quote. Or I'm sorry, and the open parentheses. Now the open parentheses, I'm going to need quotes around because that's a special character in the expression language, and I don't want it to be interpreted as a special character. I just want it to be interpreted as a plain parentheses. So I'm going to put quotes around that, but then I want no space between that parentheses and the mg for milligrams. And then I want space between the mg and the L to the -1 because it's always good to have space in between the units. And finally, just as before, I have no space and then my closed paren for the end of my expression. So this should give me something that looks very similar to what I already had, but now I've created it entirely out of the language we use for building expressions as opposed to putting more of it in quotes. Let's make sure this works. And I'll go back to the graph, and it really doesn't look that different. It really has the same effect. So again, I've created space here with a tilde, no space here with an asterisk, a little space here with a tilde, no space here with the asterisk. And just to give you a little bit of what goes wrong, I can actually delete that tilde and I'll show you what happens. Actually, RStudio can already tell me I'm doing something wrong because it knows that needs to be an expression and it won't work, but I can go ahead and run the source, and again I get an error saying I don't know what's going on after concentration. You've got the word concentration and something in quotes right after it, and if I'm building an expression that doesn't make sense. I need to see either an asterisk or a tilde. So again, we need that, we need that tilde there, and that should fix the problem. So that's just a quick overview of how you go about adding mathematical notation to a graph. And if you look at plot math, the help for plot math, you'll see a lot more of the mathematical notation that you can add using all of these different codes in your expression.